Hello! Welcome to today's lesson on reflection and the law of reflection. We will begin today's lesson by exploring reflection on a general level and understanding that there are two types, specular and diffuse. Next, we will learn the law of reflection and how to apply it. Finally, we will look at some applications of reflection. So far, we have covered the basics of waves, including their properties and behaviors when interacting with different mediums. This knowledge serves as a foundation for exploring how waves reflect off surfaces. Building on this foundation, today's lesson will deepen our understanding of wave behavior, in particular reflection, equipping us with the tools to predict how waves interact with various surfaces. This is essential for practical applications in both technology and everyday life. Let's get started. Reflection can be divided into two main types, specular reflection and diffuse reflection. Specular reflection occurs on smooth surfaces, such as mirrors. When a wave, like light, strikes a smooth surface, it reflects in a single, predictable direction. This is why you can see a clear image in a mirror. The light rays bounce off in a uniform direction. In contrast, diffuse reflection happens on rough surfaces, like brick walls. When light hits a rough surface, it scatters in many directions because the surface has many angles and small imperfections. This scattering causes the reflected image to blur or not be visible at all. For the purposes of this lesson, when we refer to reflection alone, we are focused on specular reflection, which is the clear, predictable kind that occurs on smooth surfaces. The law of reflection is a fundamental principle that governs how waves, including light waves, reflect off surfaces. The key concept here is that the angle at which a wave strikes a surface will equal the angle at which it reflects off. Let's break this down with a diagram. Let's label the light ray that hits the mirror our incident ray, as in the initial incident of the light ray hitting the surface. Let's also call the light ray reflected from the mirror the reflected ray. While we're at it, we'll draw a line perpendicular to the mirror called the normal. This bisects the angle formed between the incident ray and the reflected ray. Let's call the angle between the incident wave and the normal the angle of incidence. Let's also call the angle between the normal and the reflected wave the angle of reflection. The law of reflection states that the angle of incidence is equal to the angle of reflection. In other words, if a light wave hits a mirror at a 30-degree angle relative to the normal, it will also reflect at a 30-degree angle on the other side of the normal. Understanding the principles of reflection is critical for numerous real-world applications. Here are a few examples. Mirrors rely on smooth surfaces to provide clear reflections. When you look into a mirror, light from your face hits the mirror and reflects back to your eyes, allowing you to see your reflection. The predictable nature of specular reflection ensures the image you see is clear and undistorted. We will examine exactly how mirrors work in greater detail in an upcoming lesson. Another use case is reflective coatings. For example, solar panels often have reflective coatings that help direct more sunlight onto photovoltaic cells. This maximizes the amount of light energy converted into electrical energy, improving efficiency. Echoes are another example of reflection. When you shout in a canyon or a large empty hall, the sound waves travel to the walls, reflect back, and you hear an echo. This occurs because sound waves follow the same principle of reflection. The angle of incidence equals the angle of reflection. This principle is also used in architectural designs to enhance or control acoustics. In today's lesson, we delved into the concept of reflection and the law governing it. We explored two main types of reflection: specular reflection, which occurs on smooth surfaces like mirrors, and diffuse reflection, which happens on rough surfaces like brick walls. For the purposes of this lesson, we focused on specular reflection. We then learned the law of reflection, which states the angle of incidence equals the angle of reflection, when both are measured relative to a normal line drawn perpendicular to the surface at the point of incidence. We finished off by discussing some practical applications of reflection. This lesson has given us a solid foundation in reflection, which we will further build on in the next two lessons. Watch the rest of the GCSE physics course at Sophos Education.